Okay, well, this is the video for section 8.4, graphs of the other circular functions. Today we're going to show you guys how to graph the cosecant, secant, tangent, cotangent. Okay, so they look a little weird, but we'll get through it. So we're going to start with the graphs of the cosecant and the secant functions. The cosecant values are the reciprocals of the sine values. So when the sine equals 1, the cosecant equals 1. And when the sine equals -1, the cosecant is also -1. So those reciprocals are, when it's 1, the reciprocal is also 1, and the same thing for -1. And when the sine is positive between 0 and 1, then cosecant is also positive, but it's always greater than 1, right? If we take the reciprocal of this fraction, we're going to get a number that's bigger than 1. And so the same thing when it's a negative, we're going to get a value when we take the reciprocal of this number that's between -1 and 1, we're going to get a number that's way smaller than -1. So when the sine, absolute value of sine approaches 0, the absolute value of the cosecant gets larger and larger, and the graph of y equals cosecant approaches a vertical line. So it becomes an asymptote when x equals 0. So when the sine equals 0, we're going to get an asymptote. And in fact, the vertical asymptotes are every value of pi, right? This means that the lines that when x is a multiple of pi, we're going to get a vertical line. Okay, so similar analysis for the secant function can be done when that's the secant goes with the cosine. And what we need to do to graph this is that we need to graph the guide function, they call it in the book. And so to actually graph the secant function, you would graph the sine of the secant x, you'd graph the sine of x. And when you would graph that, this would be where it crosses the x-axis, that's going to be your vertical asymptotes. And where it has a peak or a valley, that's going to be a min or that's where the cosecant is going to turn around and go back the other way. So it's going to have these asymptotes where it's a positive on this side, always negative on this side. It's going to make these U shapes between the two asymptotes. And it's going to go up to the minimum on the sine curve. Is going to go down to the maximum on the sine curve here. And the same thing for the secant and the cosine. You would plot the cosine as your guide function, and wherever the cosine was 0, you're going to get an asymptote, and where it was 1, you're going to get a positive values on this U shape like that. So it's not too hard to do. You just have to realize that it's the inverse function. So the sine or the cosine just goes up and down like it does, but we're going to get these asymptotes. We're just going to get these U shapes for the cosecant and the secant functions when we graph those. So the cosecant is discontinuous whenever x equals 0, and that happens at every pi value, right? There's no x-intercepts, there's no amplitude. Its period is normal period without any shifting is 2 pi. And symmetric with respect to the origin is an odd function. The secant, same basic thing, but it's a little offset from the other one. Vertical asymptotes when the cosine is 0, and that happens at this 2n plus 1 times 2 pi over 2. It doesn't have any x-intercepts. Its period is 2 pi. It doesn't have any amplitude because it just goes up on these asymptotes, and it's symmetric with respect to the y-axis. So it flips back and forth, and it's an even function. Okay, so to graph these, the cosecant or the secant, you start with your guide function. If you're doing the cosecant, you start with sine of if it's cosecant, you just do the same thing just replace it with sine and graph that as your guide function. And the same thing with secant, you graph the cosine as your guide function. And wherever the sine or the cosine hits the x-axis, wherever it has a x equals 0, then you're going to sketch an asymptote. So you got the vertical asymptotes every time the sine or cosine hits the x-axis. And then you're going to have a U-shaped at the top, at where these sine or cosine have a max, you're going to have a U-shape going up. Where they have a min, you're going to have a U-shape going down. Okay, so I want to graph this one. So that's the secant. So we're going to graph the guide function is going to be the cosecant. The period, one period of the graph, as long as the interval satisfies inequality, or yeah. So we figure out the period is 4 pi. So we divide this into 4 equal parts: 0 pi, 2 pi, 3 pi, 4 pi, and we graph the cosine. Right, it goes to go up 2 and down 2 with a period of 4 pi. Okay, so this is what the cosine curve would look like. Where it hits the x-axis, we create these asymptotes. And then we sketch in the secant in solid lines, like this, where this would be coming down and going up, coming down and going up and going down. So it's not too hard. If you can graph the sine or the cosine, you can graph the secant or the cosecant. Now the tangent function is different because it's secant, it's sine over cosine, so it's going to have a period of pi. It doesn't have any amplitude, it just goes off into infinity. It's also going to have asymptotes because where the sine is 0, it's going to be 0. Where cosine is 0, it's undefined. And it's going to normally, without any phase shifting, it's going to go between negative pi over 2 and pi over 2. That's the basic y equals sine x. And the x-intercepts are every pi value apart. So negative pi over 2 to positive pi over 2, he's going to get an asymptote. So these are their own unique things. There's no guide function for them. You just have to learn how to graph those. So this is what a typical sine, the base tangent function looks like. Cotangent is the reciprocal of that. So instead of being increasing everywhere like the tangent was, tangent's increasing everywhere. The cotangent's decreasing everywhere. It goes down from one side to the other. And it's also offset a little bit. So it's offset, it goes down through, instead of going through the origin, it goes through pi over negative pi over 2 and positive pi over 2. It still has a period of pi, no amplitude, and it decreases throughout its interval. The x-intercepts are whatever values of 2 plus n times pi over 2. So this is what the cotangent looks like. This is what the sine looks like. Okay, so the period is normally pi. We just mostly wanted to figure out where the asymptotes are, where it crosses the x-axis. That's mostly what I'm worried about. These other ones, not so much. Okay, so to graph it, the period is pi over b, so instead of 2 pi over b for tangent or cotangent, we do pi divided by b. And we locate the two vertical asymptotes and solve. To do that, we solve these two equations. So bx equals negative pi over 2 and bx equals pi over 2. Okay, so wherever b is, we solve that. We put that in there and then we solve for x. We put the b in here and we solve for x. And that gives us our place where the asymptotes go. Then we sketch the two asymptotes, and then really all I want you to do is figure out where it crosses the x-axis and make a nice smooth curve on that. So for this one, cotangent of 1/2 2x and the 1/2 in front of here, there's really no amplitude, so it doesn't matter too much on graphing the sine on the tangent or cotangent. It just goes up a little faster. It gets to the, if it has a 1/2 into it, it takes a little bit longer to get to the asymptote than if it had a bigger number there, but they look pretty much the same. So we get the asymptotes at x equals 0 is 1, and we solve it for 2x, that's our b number, is 2, 2x equals pi. So the other asymptotes at pi over 2. And so halfway in between there is going to be where it crosses the x-axis. Now the asymptote it goes it, and the other points in between would only have a value of, normally go up at 1, but since we have that 1/2 here, if you want to be exact about it, you plot that point at 1/2 and 1/2, right? Because that's what that does. Okay, so but I'm not too worried about that point. I'm worried about getting the asymptotes right, getting it going. If it's cotangent, it's always decreasing, and going crossing the x-axis at the right place. That's the main thing I want you to do when you graph those things. Get the asymptotes in the right place and get it crossing the x-axis in the right spot. Okay, so that's the end of the show. So click on the form, fill out the form, and I'll see you guys in class tomorrow.